What's up, everybody? This is the Helpful Hacker here. Today we're going to be going over the HTTP in detail room from TryHackMe. So we'll get started, jumping into task number 1. What is HTTP or HTTPS? So here it gives you a brief kind of background about HTTP. And it's basically the rules that have been put forth and universally accepted at this point for communication with web servers to transmit web pages, HTML, images, videos, pretty much anything. So when you reach out to a web server, you're going to use either HTTP or HTTPS. They both stand for Hypertext Transfer Protocol, but this S at the end stands for secure. So that just means it's encrypted. So if I were to request something from a web server using HTTP and somebody else were to be monitoring traffic, they could see everything in plain text. Whereas if I'm talking to a web server with HTTPS and they're monitoring traffic, they would not be able to see everything in clear text. It would all be encrypted. And as we move on, you'll kind of be able to see the difference once we get into stuff like Wireshark. But yeah, so that's HTTPS. It's universally how web servers, send stuff, right? How they send resources and how we, the users or the client, request resources. So if we go and view this site, we get TryHackMe, tryhackme.com. If we look up here, just from what little we've learned about HTTP, we can see it says HTTP and not HTTPS, which means this isn't secure, hence why they have that little lock symbol with the dash through it. You've probably seen stuff like this on your own web browser. So you click on that, and it gives you THM invalid HTTP cert. So you'll copy that, you'll come and paste it in the bottom, and that's the answer to the bottom question. And then it'll ask you, what does HTTP stand for? Hypertext Transfer Protocol. What does the S in HTTPS stand for? That stands for Hypertext Transfer Protocol Secure. So go through that, answer those. Once you've done that, you're finished with task 1. Next, task 2, requests and responses. So how do we ask for stuff from these web servers, and how do we know what to ask for? How do they know what to give us? Blah, 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 the whole thing. URLs are a big part of this, so we're going to talk about that. So when we make a request, we're going to be asking for something, right? Like HTML, images, and we need to tell the browser where to go get the resource. So that would be our request. And if you look, we're going to learn about URLs here. So a URL is predominantly an instruction on how to access a resource on the internet. And then it breaks a URL down into its different parts. Now, most URLs do not use all of these features. These are just, the features that a URL could use. More often than not, we'll have a URL and it'll be like HTTPS, because most of the time we're using secure, Hypertext Transfer Protocol Secure. It's not going to have this user at, it'll just be like HTTPS tryhackme.com / HTTP in detail. But we're going to go through and break down all of these, because you may see, at some point, you'll probably see all of these features in a URL. So first is the scheme. This just tells us the protocol that we're using. Are we using HTTP? Oh, it didn't mean to do that. Are we using HTTP, HTTPS, FTP? So that's what that first part is. Then it's going to give us a user. So this is only for some services, and they require authentication to log in. And you can put a username and password right there. So in our case, and more often than not, when you're just browsing the web, you don't actually need a username and password, because you're just browsing the open web. So it's not a big deal. But if you ever needed to use one, that's where you would put it. Then you have host, which is the domain name or IP address of the server you wish to access. So more often than not, we're not going to put an IP address. That's why we talked about DNS in a previous video. If you don't know what that is, go check out the DNS in detail video that I posted. So TryHackMe.com, that's the domain name. That's one that we see all the time when you type in Google.com, Facebook.com. That's the host or the domain. Then you have the port, right? We've talked about ports in previous videos. So it would be the host or domain name semicolon port. That's how you access a specific port. Usually by default, most of the time you're on the web, you're going to default to port 443. So you don't actually have to type that in. It'll just kind of do it for you. And that'll take you to HTTPS or port 80, which would be HTTP. But like it says here, technically you could be requesting something from any port. So port 1 to 65,535. So there's a lot of options there, but universally we've accepted these two as what we use most often when we're browsing the web. Then you have the path. So this is the file name or location or the file path to the actual resource you want. So let's just pretend for this example, let's say TryHackMe has the pre-security pathway, and then in that they have a web module, and then in that web module they have DNS in detail. So what you would do is it would be a / pre-security pathway / web module / HTTP in detail, right? So it's the actual path for what you're looking for. And that goes right after your domain, more often than not, because most of the time we're not using a port. Then you have a query string, and this is extra information that can be sent to the requested path. So here they give the example, like if you want the very first blog ever published on a website, you can maybe try ID = 1 after that question mark. And then that might get you the very first blog that has been published, right? And then you could change that number and access different blog posts. So that's additional information. And then fragment, you really don't see this one a lot. This is a reference to a location on the page that you've requested. And this is used if like you have a page that has a ton of content and is super long. So those are all the parts of a URL. Good to know. It's always something to, that you can look back at. So that's helpful, but you should kind of know all these different parts and what they are. Now, making a request, you can make a request super easily. Just get /HTTP /1.1. So the request method is get. We'll talk about more of those in a later task in this room. The protocol version, that's going to be the HTTP 1.1, and then you're requesting the page. That's a basic GET request. You can see it right there. So we're going to go through this. This is going to break down a request. So the first part of the request is you're going to have the method, and in this case, you're requesting the home page with the /. So that's what the / is right there. So if I wanted to get something else, like let's say instead of getting the home page of TryHackMe.com, I wanted to go get TryHackMe.com /admin, I could type in there /admin, and that would attempt to get the /admin page from TryHackMe.com. So that first line is sending that GET request. It's using HTTP protocol version 1.1. We can see that. Then line 2, this tells the web server that we want the website TryHackMe.com, right? It gives the host. Then we have the user agent. So this is the browser that we're using to make this request. And then we have the refer, which is which web page referred us to this TryHackMe.com address, and it's TryHackMe.com. And then the last line of any GET request is a blank line so that the computer knows the request is over. So that's important to include. And then an example response is right here. It'll respond with a code. In this case, you get code 200, which means that the request was completed successful. Like, yeah, no problem. And they got us the TryHackMe main web page. So that's what the first line is telling us. It's also telling us we're using HTTP. We're using, 1.1. Then it's going to tell us the server. This is server information about the actual web server. And so you'll learn a lot more about trying to find information like this, because if you have an outdated web server, you can find it here sometimes, not always. And then line 2, that's going to give us, or line 3 is going to give us the date and time. Then we have the content type, which is on line 4, and that's just going to tell us what information is being sent. Like, are we getting HTML? Are we getting images? Are we getting videos? Are we getting PDFs? Are we getting XML? And here we can tell we're just getting text or HTML. And then line 5 is the content length. So this is how long the actual content is. And that's useful because then you can confirm that no data is missing. And then after that, you have the space, which is going to tell it that here is where the HTTP response ends. And then after that space, you have all the data that you actually got, which is this HTML or text as shown in the content type. So go through that, try and understand those examples, and then it'll ask us a couple of questions. What protocol is being used? We saw it a bunch over and over again, this HTTP 1.1. And then what response header tells the browser how much data to expect? That would be content length, right? And so that content length corresponds to how much data we're actually getting. So answer both of those, and with that, you are done with task 2. Next, it's on to task 3, HTTP methods. So like I said, we were going to talk about methods later. Now we're talking about it. So GET requests. This is when you're asking for information from a web server. So you want something, maybe it's an image, maybe it's a PDF, maybe it's a web page, whatever. So HTML. So that's a GET request. The POST request, this is for submitting data to a web server. So if I, for example, log onto a website and I create a new user and I name that user 25 and give it a password of 2000, just something stupid, then if that post request is accepted, that web server is now has accepted that and is creating a new record that shows there's a user with this name and this is their password. So that's what a post request does. So GET and POST are pretty much opposite. This is most of what you're going to see on the internet. You're going to be asking for stuff, and sometimes you will be sending stuff to the web server, not just requesting that it give you things. And then you have a PUT request. You don't see this nearly as often, but this is used for submitting data to update information. So a POST request is if you're providing new information, like creating a brand new user. A PUT request would be more for something like, I want to update my password to something new. That would be a PUT request, because that information, the current password already exists. You just want to update it. And then there's a delete request. So you can delete information or records from a web server if you so request it, and if the web server allows it. A lot of web servers will kind of avoid letting you do this, depending on the web server, what it's used for, and other stuff, because as you can imagine, this could be used maliciously, and someone could go through and try and delete a bunch of records off of a web server if the web server were vulnerable. So these are just some of the most common requests. There are other requests, but you'll learn about them as you go on. So what method would be used to create a new user account? Again, new information, that's going to be the POST request. What method would be used to update your email address? That would be the PUT request, because it does updates. And then what method would be used to remove a picture you've uploaded to your account? The delete method. what method would be used to view a news article? That's a get method, right? Because you're asking for something from the web server. So answer those, and then you're done with task 3. Next is task 4, status codes. So there's a lot of status codes. You don't need to know all of them. What you should know are the general categories. So 100 to 199 is an information response. And then 200 to 299, that means some sort of success. So the request was successful. And then 300 to 399, these are used to redirect the client's request to another resource, right? So this can be a different web page or a different website. So anything in the 300s is going to be a redirect. Anything in the 400s is going to be a client error. So that means it's an error on our side. Like maybe it's an error with our browser or data that we input. So that's on our side. If you get a 500, then that means the issue is most likely on the server side. And so that's kind of what that tells you. And so these are the big general categories that they have. You will not see all of these. You usually see only a handful from each of these categories, and we'll go through the most common ones right here. So a 200 is just a request was successful, all good. A 201 means a resource has been created. So like when you make a new user or something like that. And then a 301, and if we look back here, 301 is a redirection. That means whatever you're asking for has been moved permanently. And so this will redirect the client's browser to a new web page or tells the search engine that the page is moved somewhere else and to look there instead. So basically, exactly what it sounds like. It's been moved, so redirect. A 302 means it's been found, but, and you'll see this found thing, but it's a redirect, and so it's somewhere else, and it's been a temporary change, and it may change again in the near future. So redirect, right? Knowing the exact distinction between all of these is not super important. You can always Google, like if you're on the web, and if you ever get one of these like 404, 405, or 300, 302, you can always Google what they mean. But again, especially the broad categories, you should know these. So a 300 is going to be a redirect. And then a 400 is a bad request. So that's a bad request on our end. So something in the browser, like we're missing something when we sent the request. We didn't do it right. Maybe we didn't provide all the correct data or something else that the server was expecting. And then a 401, again, going back up here, that means there's a client error. So that means that we are not authorized, the client, to access that content, right? And then you also have 403, which is forbidden, which is just another way of saying, hey, you're not allowed to be here. So this means you do not have permission to view this resource, whether you are logged in or not. Whereas the 401 means if you're logged in with the right username and password, more likely than not, you probably can access it. And then a 405 means the method is not allowed. So for example, if we send a GET request to something that the web server says you're not allowed to get this information, you can only post to this location on the web server, then it's going to say your method's not allowed, right? So that means we have to change our method. So maybe we try a post request and we get a 405, then we can try a GET request or whatever it may be. And then a 404 means page not found. So that's again on our side. So whatever URL we typed in, it can't be found. And then all the 500s up here are server errors. So that's an internal service error, or that's a 500, and then service unavailable is a 503. And you can read about both of those, but basically that's a problem on the server side. So let's go through and answer the questions. What response code might you receive if you've created a new user or a blog post? If we look up here, that would be the 201. A resource has been created. What response code might you receive if you've tried to access a page that does not exist? So that's on our end. because we tried to access the page, so we know it's not the 500s. And then we can see page not found. It does not exist, so that's a 404. What response code might you receive if the web server cannot access its database and the application crashes? So that's a 503. So we can look, the 500 is the server's encountered an error with your request and it doesn't know how to handle it. Whereas a 503, the server can't handle your request because it's either overloaded or down for maintenance. So if the application crashed, then we would most likely be getting a 503 error. And then the last one, what response code might you receive if you try to edit your profile without logging in first? We talked about this in the 401 or in the 401 and 403, right? This one, you don't have permission to view this whether or not you're logged in. The 401, usually if you're logged in, you can probably access it. So here they're saying without logging in first, so we're going to assume that's the 401. So those are some common HTTP status codes, which are good to know, like I said, the general ones. And then I almost forgot, they have this view site here. So we can actually look, or not. Just kidding, it's going to make us refresh. Back to status codes, view site. So we can just see examples. So this is a 403 forbidden. This is what a 404 error looks like. This is what a 503 error looks like. And I'm sure you've seen these before. So yeah, you can click through those. And once you've done that, you're done with task 4. Next is task 5, headers. So headers, again, they're additional pieces of information that you can send to a web server when you make a request. So yeah, this is something that you'll see a lot of if you're looking at HTTP requests. Some common request headers. So if it's a request header, right, that means we sent it and it's something like host, that's a common one. Or user agent, which we've already talked about, content length, which we've already talked about and we showed in the requests and response examples. So if you look at those are all headers. So yeah, those are headers. Here are some common ones. Some new ones that we didn't look at previously, accepted encoding. So what kind of compression the browser supports and wants to use. And then cookies. Cookies are just data that are held to help remember who you are, basically. That's how I like to think of it. And then some response headers are set cookie. So the web server will tell you like, hey, here's this, keep track of it. Here's this cookie that tells us that you are you. So whenever you respond to us in the future, use this cookie. And then things like cache control, how long should you store the content of a response, content type, which we've already talked about, content encoding. So what method did the web server use? Because again, this is a response header to compress that data. So let's go through, answer the questions. What header tells the web server what browser is being used? That would be, if we go up here, user agent. What header tells the browser what type of data is being returned? That would be content type. And then what header tells the web server which website is being requested? That would be the host. So go through, answer those, and then you're done with task 5. Task 6, cookies. So again, we've kind of talked about cookies somewhat, and it gives us a really good example. So we're going to ask we're just going to read through the example. So a client requests the web page from cookies.thm. The server responds back with a web page, and in the web page is a form asking for a username, right? So we, then the client, fill out the form and we set the name to Adam, and then we send that form back to the web server. The server takes that form, processes that information, and then responds with a set cookie header. And this gives us a cookie and tells the client to save this cookie. So we save this cookie, which is name equals Adam. That's the cookie. And every single request that we do from there on out, we're going to include this cookie, name equals Adam. That way, the server knows who we are and can do customized things for us, right? So here, because we sent the next request with our cookie, the server is going to respond. And because the server got this cookie, it knows, oh, this is Adam. So it's going to respond. And instead of giving a generic hello message, it's going to say, welcome back, Adam. And it'll actually use our first name. So that's kind of a quick overview how cookies work, a quick example. They're basically going to help the web server remember who you are. And that way you can save information on a website, such as like settings or, whatever else. So you can read through all that, click on this view site. This is just going to show you how to access cookies on different browsers. Because if you want to right now, you can actually just in your browser look up all the cookies that you currently have saved that tell websites stuff about you. So yeah, that's task 6, cookies. Answer those questions. Take a look at the cookies on your own browser. And then once you've done that, you're done with task 6. Now task 7, making requests. So this is an emulator for making HTTP requests. So we got to use what we learned from above to make a bunch of requests. So let's start. So we got methods, we got the URL, we have the send request. So that's when you're just sending it. And then you can update your get and post parameters in this little setting icon. Cool. So make a get request to /room. I assume it means on TryHackMe.com. So I'm going to just leave it there and do /room. Send that. And now, if we look, like we talked about earlier, we get, and instead of just getting TryHackMe.com, we want /room. And then it's going to give us a 200 response. And if we look at the data, here is our flag. We can copy that flag, paste it in there. And that's the answer to the first question. Now make a get request to /blog. So let's do /blog. And using the gear icon, set the ID parameter to 1. So we're going to set the ID parameter to 1. And we'll save that. And then we'll proceed. And here we go. You found the blog. That's our next flag. So you can copy, paste that in there. Now we're going to make a delete request. So we got to change the method. And we're going to send that to user /1. Is there anything else? Nope, just that. So we should be able to send that. And here's our flag. User is deleted. So that's good. Now we got to make a put request. What are we putting to? User /2 with the username parameter set to admin. So we're going to do username, and we're going to set that to admin. And now if we proceed with that, send it. THM user has updated, because again, we put that put request. Now we're going to post. So we got to change for the last question to the post, the username of THM and the password of let me in to /login. So we're going to go to the login and we're going to set, I already have one. I'll just set another one. Username, and the value of that is going to be THM. Save that, and then password. And that is going to be let me in. Save that. And now if we post that, you're logged in, welcome back. We can copy that flag, paste it in there. Once you've done all that, you've answered all of the questions and you've finished task number 7. If you found this video useful or helpful at all, please give it a like, subscribe. It helps me out a ton. And once you've completed all 7 tasks, you have finished the HTTP in detail room from TryHackMe.